So today I'm going to talk about environmental policy in the United States. Unlike the last time I saw most of you, there are no derivatives. I do have one economics diagram. That's the sum total of the economics I have, and that will come in a moment. And after that, I'm simply going to describe, as they say, laws and sausages. And the joke there is that law, like sausages, are not something you want to see made. So there will necessarily be some discussion of the interactions I've had with these laws and things I've done, and so there will be a bit of storytelling, and there will be a bit of just, these are the laws and these are how they work. So where we start this is the idea of a technology-based effluent standard. And if you're going to write down one thing in the whole lecture and draw one picture in the whole lecture, it's what happens in the next 3 minutes. Actually, I'm going to ask you to draw the picture. So you need a straight edge, and you need, and you need a pen, and you need a piece of paper. So standards, as by now you know, can be written in a whole bunch of different ways. You can write standards in terms of output. So the water permit system in the United States gives discharge permits as a function of plant capacity. Not output, but capacity. That's an example of a realistic system. What's wrong with the system is just what you think. If a plant runs, a paper plant runs very rarely at capacity, and you gave it enough discharge permit for capacity, then the discharge permits will not be binding most of the time. That's the actual situation in water in the United States. But the idea is an emissions permit per unit. I can emit so many grams of bleach for each megaton of paper I process, right? That'd be standard per emission output. You can also do standards per emission input. The notorious case there is coal and the United States. So we have two types of coal. We have low sulfur coal and high sulfur coal. So if you had a permit of the form, so many grams of sulfur per megawatt hour of power, then people would choose the coal that had the least sulfur to meet their permits, and that would be the cheap way of doing it. The result would be the people who had the high sulfur coal would have no market left, and so what they did is they did an input standard, and their standard was that 95% of the sulfur that was in the coal had to be removed. And of course that no longer makes it advantageous to have low sulfur coal, because all you'll have to do is fight to get the last little bit of sulfur out. But it's an example of an input standard. So many grams of this per so many grams of that input. Right? So we have input standards, we have output standards. Next little bit here is it says that the sulfur standards were a precursor of the way it's now done in the Clean Air Act, CAA. So from here on out, if you see CAA, it's Clean Air Act. If you see CWA, it's Clean Water Act. So what about a technology standard? So now we have standards per unit input, standards per unit output. Now I have the last thing, a technology standard. Technology standard is something like a building code. You want to build this building, okay, then you got to have those, triple insulated windows. You don't have a choice. It's not you have to achieve an overall rating on your building of insulation of R32, and you can distribute it between the walls and the windows how you like. There's no choice here. You must have them windows. That's a technology standard. Another example would be you must have a catalytic converter on your car. That would be a technology standard. Actually, the American car standards are not technology standards. The car standards are really of the form you must emit no more than so many grams of NOx and SOx and reactive organics per mile. So the actual standard for cars is an emission per output standard. Now, what you do to meet this standard is you put a catalytic converter on your car. But the standard isn't the catalytic converter. If you could meet the emission standard in a way other than a catalytic converter, you would be welcome to do this. Nobody knows how. It hasn't been done yet. But sooner or later, somebody's going to say, why do I need to put on my car a thing that's this big and has platinum balls in it to change NOx into whatever it does, burns it further. Now, why do I need to do this? I have a way that won't cost $500 a car. If someone does that, they're welcome to it, because it's an emission standard. It's so many grams per mile. It's not a technology standard. It's not, you must have this box with the balls in, right? So now we have two fundamental types of standards. You know, or we have something that's so many grams per output or so many grams per input, right? And those are emission standards. And we have technology standards. Technology standards is, you will do it my way, and this is my way. Put the windows in the way I told you. Now I have the different types. Now we have what we actually do. What we actually do is a technology-based effluent standard. So you're going to decompose it, go from the far side. At the end of the day, it's an effluent standard. But how does the effluent standard get set? Well, one piece of setting the effluent standard is that we must find a technology that will do it. So for cleaning up carbon dioxide emissions from cars, the state of California went out and got itself a bunch of automotive engineers. And it said to them, guys, we want to be able to cut the amount of CO2 per kilometer from whatever number of grams we had to something like half that. How would you do it? And the engineers went off into their engineering world, and they came back with a number of technologies that would do the job. The technology that did most of the job is simply a change in the transmission of the car. So if you put a 6-speed rather than a 4 or 5-speed transmission in a car, then you can get 12% of the emissions out of the car. So now they have a basis to require the companies to drop their emissions by 12%. But in the end of the day, they tell them, whatever it was we used to have, now you will emit 12% less. You want to do it with a fancy transmission? Sure, go right ahead. You want to do it with an engine that burns stuff on a completely different principle? You go right ahead and do that. You want to increase the amount of your fleet that's electric? Be my guest. However you want to do it. But you got to get 12% out of your fleet, because we know a way of doing it. We have a basis for this rule. So that's a technology-based effluent standard. There's a technological basis that you can look at, you can hold in your hands, and if you did that, you would get rid of some amount of emissions. That is the basis, and because we can do that, we can simply flat out require you to have less emissions. So that's technology-based effluent standards, and they are the form of standards in the Clean Water Act and the Clean Air Act, and I know of no other form of standards in American jurisprudence. Now we have our one piece of economics. This is a standard isoquant-isocost diagram. What I'd like you to do in the next 60 seconds is do a crude, fast copy of it onto something, because I want you to draw one line. Okay? So it should not take long. You're drawing an axis. It's got two inputs, other stuff, which I'll just call other, and clean air services, which I'll abbreviate clean air services, right? So when you use more clean air services, that means you throw more crap in the air. The air is just a big garbage truck. So the way we view this is a very standard model. We view polluting as simply using, environmental services to remove your garbage. So as you go this way, you're removing more garbage. That means you're throwing more crap in the air. Yep? That's the way I teach it to undergrads if I had to do it. And I do have to do it. So it's no joint product stuff. It's just another input. Technically, it's the same. Now I draw an isoquant, right? And do you know what an isoquant is? Someone give me a fast definition. Come on. Yeah. So it's same production. Iso is same, quant is quantity. Same quantity of output, different types of inputs. Then I drew an iso cost line, and I drew a tangent, right? And so now I found the least cost way of producing whatever this output is, assuming there's some cost to the air. And the way I assume there's some cost to the air is it's not free to throw things out into the air. You actually have to use energy to do it. Cars use quite a bit of energy to get rid of their exhaust. So it really is not free. So I get a real standard diagram. And then the story is the engineers come along and they say, aha, I know a way to produce this level of output and to do so with less clean air services. And that's this star here. Okay, so, quick economics 100 quiz. Can you have a technology that is not on an isoquant? Is that possible? Can you have a technology, this amount of clean air services, this amount of other junk, right, that is not on the isoquant and yet does produce the same number of kilometers? Is that a possibility? Why? What is the isoquant? I mean, she gave you half the definition. It's the set of efficient techniques that produce the output, right? So that could be an inefficient technique, could it not? Well, I do. This is the set of all efficient techniques to produce 100 kilometers of travel. This is a technique that produces 100 km of travel. But it uses strictly more other stuff than an efficient technique. Yes?
Yeah.
Okay, so is it an efficient or inefficient technique? Okay, so you put the gasoline in your tank, and in the inefficient technique, a kid with a straw comes and siphons some of it away. You still only go 100 kilometers, but you use more gasoline than you would have. That would be an inefficient technique. Remember, efficiency is, I have a chocolate bar. Unfortunately, I don't have one with me today, and we're going to share the chocolate bar, and I break it, and some of it falls on the floor. That's inefficient. I use an engine in my car that costs as much but burns less efficiently. Yeah, inefficient technique. Okay? So the last thing I want you to do is I want you to draw, and you get 45 seconds, draw me one more line on this diagram from which I can infer what the costs of the inefficient technique are. Right? So I want to know, what's the cost of this technique? And if it make you much happier, you can say the price of other goods is 1. Price of clean air services, I don't know, which is greater than 0, and I don't care. Okay? You need to draw one more line. It's a straight line. Yeah, you need to draw one more isocost line. You just can draw me a parallel shift, yeah, all day long. Sure. So he's going to draw me a parallel line. These two lines are parallel, so they have the same prices. Now, since the price of other goods is 1, this distance is what the efficient, the original technique cost. This distance is what the engineer's proposal cost, but will the firm actually do the engineer's proposal? Remember, the form of the standard now is I made the proposal and you can use any amount of clean air services so long as it ain't more than this. So what's the least cost way of doing that? The initial point's now infeasible because you can't use more than this amount of clean air services. So you're limited to being over here. If we had colors handy, we could shade this all in red or something. So you got to be over here. This is above the isoquant. What's the obvious thing to do? What should I do? I can't move the isoquant. It's what it is. That's the set of efficient techniques. This is an inefficient technique. This inefficient technique costs all this. I need to do something else that has this amount of clean air in it. I could do this, but is there something cheaper? So I can come straight down, right, to here, okay? And so now you can draw me one more line. Here, one more price line, right? And so this is that's what the TBES actually costs. And it's less than or equal to what the engineer's proposal is. In cases I know, or more to the point, what my friends at ARB have told me is that when they go to scope one of these things, the engineers say, we're going to do this and it will cost that. The companies say, oh, we'll do this, but it will cost, I don't want to ruin things, that. Right? Your company, do you want to be regulated? Anybody want to be regulated as a company? No. Okay, so if I come to you and say, a 6-speed transmission is only going to cost $1,000 and it'll save 12%, it'll be a great deal, and you don't want to do it, what are you going to say? Right, there's a public hearing, you're going to stand up, what are you going to say? You're going to have an engineer show up. What's he going to say? No. Is he going to say $1,000 is too expensive? Come on, he can do better than that. For what you pay these guys, they can say more than that. Anyone can say too expensive. But I'm an automotive engineer, member of the Association of Automotive Engineers, and I've been designing transmissions for 312 years, and I can tell you that this design will cost $1,000, $2,000, $3,000, $5,000. Which am I going to testify to? 5. 5? Actually, they testified to 3. So that's how the actual fight goes on. Government says, our engineers say you could do this, it'll save clean air, it'll cost $1,000. Their guys come in and say, no, it'll cost $3,000. And my friends who do this for a living claim when they go back afterwards and check what it really cost, not $1,500, I'm sorry, $500. So what they found was there was a 2-to-1 or more disagreement with the industry of what it would cost. And when you find out what the industry actually does do, I'm sorry, they do it all the way down here, it was on the order of half. But that is the major fight that happens. So when you go to regulate one of these things, you have to say to the industry, it won't cost you that much to clean up. You could do this. You could take your spray paint, another one I was in, and you could put the following chemicals in it rather than those chemicals. It'll have less reactive organics. It won't get in the air as much. And they will come back and they will say, oh, that would never work, the paint will never dry, you have to use these chemicals instead, and then it's very expensive. A can of spray paint will go from $6 to $30 because of what you're doing. It'll ruin us. We're small businesses, and people will go hungry, and so it goes. And that is actually what those hearings sound like. And the fight is over, is this reasonable? And they will say unreasonable. And we will say totally reasonable. And then when we come back later, of course, a team of engineers working for General Motors and producing a real item is going to come with a much lower cost than any way we can design it, because they get the better engineers. Okay? That's the basis for how we make them do stuff. And I would suggest to you that American law is widely copied. The Clean Air Act and the things that surround it are widely copied. And you will find echoes of it almost everywhere you go. If you wanted to compare to a tax, you would take your point, this is where you want them to be, let's say that's the right answer. In order to make them choose that voluntarily, you're going to have a tax. And the tax will always cost more than the standard. For which reason they always will prefer the standard to the tax. Because with the tax they have to pay for the residual they emit, and with the standard they don't. Okay, so if you really wanted to finish it up, that's how you'd finish up the picture. And that's what you want to teach your undergraduate students in Introduction to Environmental Economics. Exactly that picture, and if they can write it on the final, you give them a decent grade. And I can promise you that only about 75% of them write it on the final. It doesn't matter how many times you put it on the board. The red star? Because people are choking to death. People can't breathe. No, the Clean Air Service is the service, the environmental service that air provides in removing your garbage. It's a garbage truck. This is how much garbage truck they get. Okay? So the more garbage truck they buy, the dirtier the air is. They're buying the waste disposal services of the air. Yeah? Okay. Right? They have a big tank of CO2, and they can't continue their process unless they get rid of the damn stuff. And so they got to get rid of it. And they discover that the air will take it away for a very low price. And so they give it to the air. And the result is that everyone fries. And since we don't want to fry, we want to stop them from doing that. And in American law, largely we stop them from emitting by giving them emission standards rather than prices. Okay, is that, we're there now?
Yeah, I think so.
Okay. All right, the rest of this is all easy. The rest of this is just what did we do? So this is a big body of law. If you were lawyers, what I'm going to say in the next hour or whatever we're going to spend, hour and a little, we're obviously going to spend more than I thought because it's 40 after. They would take a year to say, right? So there's a very large body of law. The masterpiece of law is the National Environmental Policy Act. And this act is an act that makes people make plans. It doesn't do anything else. If you want to build something, you've got to turn in a plan for the thing you're going to build, and you have to, in your plan, say what it will do to the environment. Swedish law, by the way, is currently based on that as well. They have exactly the same thing, and I don't know about the rest of Europe. having turned in the plan, if you did everything properly, you're done. So you would imagine I want to build a campus, because I was involved in this. Campuses are not small things. It's 2,500 acres, so it's 1,000 hectares. It's going to be 1,000 hectares of buildings and people and labs. Yep. So we make a plan. We consider the alternatives for this plan. Well, I'm getting ahead of myself. Let me do it in the order I have it. Right. So you have to make a plan. That's the point. And the plans are expensive. There's not a cheap matter to make a plan for a 1,000-acre campus. So who has to do this? Under the federal law, any project that is a major federal action, which they interpret incredibly broadly. So if I need any permits from the United States, for instance, I want to fill an acre of what was wetland, I will need a fill permit. I want to change a waterway in any way, I'll need a fill permit. If you look at a realistic projects happen on sloping topography. There's always a place that's wet. As soon as there's a place that's wet, you're going to have to go for a permit. Realistic places that don't yet have houses on them have furry endangered creatures on them, or feathered ones, or even in our case, fairy shrimp. What do you have to do? Well, if you want to disturb them, you got to get a permit from the feds. So any decent sized project, you're going to need some kind of permits from the feds. Once you need that, you trigger the National Environmental Policy Act, and you will produce an environmental impact statement. So what is this thing? It's a detailed written analysis. I mean, for campus, we're talking this much paper. Yeah, not this much paper, this much paper. Millions of dollars, right? Detailed written analysis of the project. And if you were going to, mark anything important here, you'd say, and the alternatives and the no action alternative. So my project is to build a campus in Merced. My alternative is to build it at Mapes Ranch. I actually had many, many alternatives, but that's one. Why did I want to build it in Merced rather than Mapes Ranch from the point of view of the environment? Well, Mapes Ranch is underwater once every 15 or 20 years, and so we would have to build extensive protection from the river, and that would have adverse effects of riparian wildlife, blah, 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 blah. Whereas the site we have is mostly high and dry. Right? That would be one of the examples. And I have to explain the environmental impacts of the project and the alternatives. And then I have to say, and if we didn't build the project, then 25,000 kids would not be able to go to college each year. And so we choose to build the project. And we produce this pile of paper, and then we take it to some body. In the case of our project, our governing board is the agency that decides. And they take our proposal, and the appropriate government agency then says, yes, I see you've chosen your preferred alternative, and we agree with that. Right? So that's what's going to happen to it. So what this thing is a big plan. When? You got to do this before you start the project. You can't go out there and move a little dirt around and then come back and say, oh yeah, we see we need some permits. No, doesn't work. You may never get your permits. And you have a long calendar of things you have to do. It's not like I write the thing, I give it to whoever makes the decision, my governing board, they forward it to US EPA, and we get our permits and we're done. No. There's extensive public hearings, and after the extensive public hearings and comment periods, we've got to respond to all the comments. There might be 10,000 comments. We might actually have to employ 5 or 6 people to do nothing but take the comments, categorize them. So if 10 people make the same comment, what about kit fox? Then, you can put all 10 comments together and you can give a response. We hired so-and-so who's a blah, blah, blah biologist, and he spent 6 months with traps and locks and wraps or whatever, and no kit fox were found on the property. Moreover, kit fox only live in habitats where you can hide from hawks, and the property is entirely open, so we really wasted our money for looking for them anyway, because the hawks would have eaten them. But we were forced to do it. Another, $100,000 down the drain. So that's the feeling for the process, is that people who don't want your project are going to write a lot of comments, and they're all going to come in on the last day of the comment period. I guarantee it. And then you have to respond to them. Why do we do this? Because in the 1970s, in particular, and all of our environmental laws date from roughly the time of Richard Nixon, a conservative Republican president who signed the Clean Water Act amendments, the Clean Air Act amendments, NEPA, etc. So it tells you how controversial it was at the time. We believe that the only reason we were doing bad things to the environment is that people just didn't know. Now, this reminds me of my grandmother saying the Russian people around 1890 would say things like, if only Tsar Alexander knew of our troubles. And of course, the Tsar knew of their troubles. He actually caused their troubles. And the agencies knew what they were doing. And they knew that before they wrote these plans. So it was a very naive response. And not actually calculated to make the environment any better. That's the way people would have looked at it until the law was passed. What happened with the law is that if your EIS is defective, you get sent back to square one and you have to do the whole thing again. That could take quite some time. It could take 2 years to prepare one of these things. So if you wanted to open a campus in Merced and you got serious opposition and you were not able to produce an EIS that had all of the right words in it, you got done and you said, I don't know, the kit fox, they don't really matter. We're not going to spend $100,000 to show that a kit fox doesn't live here when everyone knows it's not habitat for kit fox. You might find that a judge said, oh, I'm really worried about this kit fox thing and you really haven't addressed it very well. I think you ought to go back and address it. And that would mean your project gets put on hold for 2 years. So you play this kind of hold-up game, if you want, with a project. And that's what made that law very, very powerful, is that it was very hard to write something that took care of everything. It was very hard for a group of ordinary bureaucrats to get right all the little pieces of the law, and any mistake was fatal and caused their draft EIS not to be certified and them have to go back to the beginning. And that's, in a nutshell, why American developers hate American environmental law. It's not that they were told you can't build on wetlands, they could live with that. They were told you can try, we'll see what happens. The original was environmental impact statement. It was United States, and then other jurisdictions did the same thing and changed the titling. But for instance, Sweden does it. I don't know what their titling for it is. You produce a report saying what this project will do to the environment. Okay, so remember, the report itself could be perfectly legal and call for the destruction of the city of San Francisco with a thermonuclear weapon. People are not an endangered species, so the fact you kill the people has no consequence in this report. You are the administrative law agency that made the report. You are entitled to the administrative law presumption that you are right. And I cannot be challenged on whether or not, ultimately, whether or not my project does or does not kill the garter snake that's endangered. That's why I can't blow up an atom bomb. I will harm I think it's the San Francisco whip snake, which is an endangered species, and that would be illegal. All right? But if I find that it doesn't, that they're well known to be resilient to thermonuclear explosions, you can't challenge that. You can challenge the fact that not only was there that, but there was also a toad who was endangered, and I didn't speak about the toad. But it's purely on the procedure. As the agency, I'm entitled to make the finding on the merits, and nothing you can do about it. So if it's down to the environmental impact and the government wants to do it, and the government's willing to devote the legal resources to doing it, the government will do it. And that's all there is to it. But the government's very usually not willing to devote those kind of legal resources. And so it plays out in a court fight about, did you remember the frog? Oh, this time you remembered the frog and the snake. Well, we've got this endangered bird for you next time around, right? So that's how it plays out. It doesn't play out in high-level politics of should we or should we not be doing this. Take the Keystone XL project. That's not playing out over the environmental impact statement. That's playing out over the agency, in this case the United States, deciding yes or no as a political decision. That's not challengeable. Once they say yes, they will have to come up with an environmental impact statement, and it will be challenged. Right? And then it'll play out in the courts, but in the silly fashion. Not in the straightforward fashion of, yes, this is a good project, no, it's a bad project. So that's how ours plays out. The politics is still there, but that's not the crux of where you have the politics. The least controversial law ever passed in the United States was the Endangered Species Act. Congress passed it with basically little debate and little or no opposition. Nobody thought for a minute that there were more than 3 or 4 endangered species, most of whom would be some sort of bear or other that was worth saving. It never occurred to anyone that plant species go extinct, or that there are really tiny shrimp that live in vernal pools that can only be seen with a magnifying glass, and that a particular variety of those lives only in the soil near Merced, California. And none of that ever occurred to anyone. They thought endangered species were furry things or maybe feathered things, and there were probably about 7 of them in the whole world. Well, it turns out that there are lots and lots and lots and lots of endangered species. Many more than one could ever list. And that is why the Endangered Species Act became such an important act. It's that it applies almost everywhere rather than just a few places. What it says is pretty simple. It says that if a species has been declared endangered, you can't take it. And defines take to be very broad. If it's a spotted owl, you can't chop down trees in which it might live. Well, spotted owls seem to need a lot of room for each pair, and so keeping a reasonable number of spotted owls in the Pacific Northwest is tantamount to cutting down no further old-growth wood in the whole Northwest. The red-cockaded woodpecker lives in the South, and the red-cockaded woodpecker needs snags. So it's a red woodpecker. It wants to peck at things that are dead, that have insects in them. And so you can't take those out. But if you can't take those out, you can't take the trees around them out either. And so the red-cockaded woodpecker shut down all forest harvesting in the southeastern United States for quite some while before they figured out how they would preserve the woodpecker and go on. So these things are not real innocent. From the point of view of a developer, you're going to need a take permit to develop your land. So you got, 1,000 hectares, of which I seem to remember it was like 26 acres, 15 hectares are wetlands. On the 15 acres of wetlands, vernal pools, so they're only wet part of the year, there's little tiny shrimp. So you have to get a permit from the Fish and Wildlife Service to obliterate the home of these shrimp. And that's how the Endangered Species Act works. What they would prefer is they would prefer a habitat conservation plan. So they'd prefer, rather than just saying, your few acres, it's okay, we'll take some other acres over here, that'll be fine. What they'd prefer is they'd prefer a plan for the entire habitat of the species. Well, if you go to Southern California, you'll discover that various lizards and toads and stuff that are endangered have as their habitat every piece of undeveloped land in Southern California. So this is not a small request to make a habitat conservation plan like that. Needless to say, most of those plans are never made. The typical thing that happens is you just have a negotiation. You say, okay, we want to take these vernal pools, but in exchange, we'll protect vernal pools on all this land over here. And they say, good enough, and they give you your permit. So if you were a law and economics type, you would realize this is just a very high tax on undeveloped land. If you want to develop, you might be forced to dedicate, well, that's not good. Well, that explains that. You might be forced to dedicate a large number of acres to conservation uses in order to be able to use a small number. So that's the Endangered Species Act in a nutshell. If instead of trying to produce something on a piece of dry land, you go for wetland, you'll run immediately into a much stronger law. Section 404 of the Clean Water Act. And what that says is no net loss of wetland. So if you want to take 20 acres here, you might be forced to make 20 acres somewhere else. An example of that is San Francisco Airport. San Francisco Airport goes out into San Francisco Bay. They want to build another runway. The runway's necessarily going to get put on wetland, and there's no other place you can put it. And so all of this stuff about I have to consider alternatives and all that, I have to do it in the least environmentally damaging practical alternative, that doesn't mean anything. You're going to have to do the project. So what do you have to do? You have to go and find land that used to be wetland, in this case salt ponds. And I'm thinking of thousands of hectares of salt ponds. And you have to reconvert them to wetlands. So you actually have to go out and build a swamp. And so to take what might be 50 acres, you are going to have to compensate them with thousands, plural, of acres of swamp that you must manufacture from old salt ponds. I don't think anyone's ever pushed that. So if it were, say, Canada geese, I would imagine you could say, well, you know, the real problem with Canada geese is this place on the flyway and it's in Canada and we'll buy blah, 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 and that would work. And you're required to protect the species. So if you give the species back the habitat, you're okay. I just don't know of anyone who's done it. And I don't think the law says anything like that. The law simply says that you've got to mitigate, but it doesn't say you have to mitigate within the US or how you have to mitigate. That's a discussion between you and the agency. So the Clean Water Act is limited to places that are navigable waterways or otherwise described as waterways of the United States. Basically, if the thing you have doesn't communicate with other water, then it's not subject to the Clean Water Act, Section 404. But vernal pools eventually drain into a river. And the river is a navigable river, meaning you can get a canoe up it. And therefore, the vernal pools are waterways of the United States. This is very, very broad and heavily fought over whether something is or isn't. So now if you think about your greenfield project, right? A greenfield project is to turn something that wasn't already a city into some sort of building type use, right? If you think about a greenfield project and you're thinking of doing it in California, you're in really serious problems here. You're going to have wetlands because the topography looks like this, and anywhere it pools will be a wetland. And you're going to have endangered species. And so you're going to have to go through this very onerous environmental impact statement, and you're going to have to go through an even more onerous piece that has to do with the Clean Water Act. And you're going to have to write your EIS, and people are going to come and challenge you over your EIS, and you could figure this is a multi-million-dollar proposition to get your permits, and multiple years. And I've talked about Merced. I don't remember the exact amount of mitigation we did. I'm thinking it was more like 30,000 acres for a very small number that we took. So we went to ranchers and we bought easements over their land so they can never be built on. And so there's 30,000 acres will remain ranches forever because the ranches are the things that are most advantageous to the vernal pools. That's a lot of money. On top of that, localities regulate land. So if you were in Oregon, you'd find that they have urban growth boundaries. And if your land lies outside the urban growth boundary, you may not build on it. That's all there is to it. That's simply another level. So if you want to do a development project in the United States, you should be a land use attorney. Because that's where most of the action is going to be in terms of doing a big development. The Clean Air Act is a completely different animal from that. The Clean Air Act was meant to make the air clean. They're very, very clear on what they were trying to do. California was the pioneer. California was the pioneer because we had a lot of people, and the people were in the LA basin, and if the air ever clears and you could see the LA basin, you discover it's on the water, and then there's a ring of mountains around it, high mountains. And the winds are not very strong. So whatever comes out of your cars or your refineries or anything else stays put, and you breathe it. That's why California regulated air in LA. It's the same story as Beijing today. We read in the newspapers, right? You should have a mask. Don't send your kids out to play today because it'd be better if they breathed less. That was exactly what Los Angeles was in 1965. It didn't have the fine sand mixed in, though, which is just straight out basking in your own gasoline exhaust. And so we regulated. And the rest of the United States wrote a law that looked very much like our law, and that's the Clean Air Act. And the purpose is human health. So the Clean Air Act starts from human health. If you talk to somebody who does this, they will say to you, we are a public health agency. Okay? We're not a regulatory agency, we're not blah, 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 blah. They will tell you every time, what type of agency are you? I've tried this. They'll say, we are a public health agency. It is our job to protect public health. That is the underlying feeling of the people who do this. And where it starts, and now let's see if I can get this for you. There are actual standards written based on public health. For instance, carbon monoxide, a primary standard meaning it's to protect public health. Secondary standard means it's to protect buildings, plants, and other stuff. The primary standard here is over 8 hours, 9 parts per million. Over 1 hour, 35 parts per million. And these were come up with by the United States, but again, there's always a fight. California wanted them tougher. So, what did we do? We went and we got our public health establishment, University of California, San Francisco largely, some of the Berkeley people as well, and we set them out to do research on the effects on humans of carbon monoxide poisoning. And one of them came up with a blockbuster. She discovered that if you go over, and I don't remember what the amount was, then some percentage of women will lose their menstrual cycle that month. And she got that written up nicely on a poster. And then we took that to Washington and we said, public health, you got to protect public health. Your carbon monoxide standards are not tough enough. Look what it does to women. We'll be all over the newspapers with this, guys, unless you go our way, right? And that's the kind of discussion that's had in terms of what should the standard be. Did I hear the word money in there? Did anyone say money? No, no one said money. There's no money in that discussion. I mean, surely guys who make carbon monoxide for a living are there saying, oh, but these women, no, they'll cycle often enough. They'll have children anyway. What's the big deal, right? And they'll be there saying that. But they can't say, or at least no one will listen to them saying, but it would be so expensive to refit our boiler with blah, blah, blah. It's not part of the discussion. The discussion is purely public health. So that's National Ambient Air Quality Standards. Then that's where the regulation starts.